Okay, so for our bell ringer, Raj, what's the first one?
Scalene.
Scalene, and we know this because it has no congruent sides. Okay. Yep, no congruent sides. And then Sierra. It is right as well. So it's a scalene right triangle. Thank you, guys.
Yeah.
Okay, next one up. How would we classify this one? Yep. Isosceles. So we have two congruent sides. And then if we were going to classify it by angle, how would we classify it?
Wait, what did I say?
It says isosceles, and the other one says two congruent sides.
I look like a P, that's why.
Okay. So if you're going to classify it by angle, is it going to be acute, right, or obtuse? Oh, Sierra. Obtuse. So it's an isosceles obtuse triangle. Okay, on the one down here, we want to find our value of x. What is the sum of the interior of a triangle? How much does that add up to? 180. So 180, and then we're going to subtract the two sides that we have, or the two angles we have. 32 minus 65. So 180 minus 32 minus 65. 83. We have 83 degrees here. And then on our next one, we have 180 minus, what are we subtracting here? 90 minus 42. We see that this is a right triangle. You could have used that theorem from yesterday, which just shows that you know it's going to be 90 minus 42. Either way, you're going to get the same answer. 48 degrees. Yep, nice job. Okay, does anybody else need more time? Okay. Yep. So right here we have our next examples. I gave you guys some time to write them down. Let's get started. So we know that the sum of the interior of a triangle is how much? 180. So we take 180 and we set it equal to the sum of the measures of the angles. So that's 36 plus 8x plus 8x. So we're going to combine like terms. 8x plus 8x is 16x. Nice job. We got to combine like terms from here. We got to get those constant terms together. What do I do first? Nice job. Subtract 36. So 180 minus 36. 144 equals 16x. Got to get x by itself.
Divide 16 from both sides.
Divided by 16 on both sides. X equals 9. Okay, our next one up. This is the one we did yesterday. We see we have an exterior angle. Do you guys remember how we calculate the exterior angle?
Nope.
So your exterior angle equals the sum of the non-adjacent interior angles. So the sum of the two angles not next to it. So that would be 40 plus 90. So what is 40 plus 90? 130. So we have 130 degrees for x. Okay, and then after that, we have a little bit rearranged. Now we have the external angle, 143. And we're going to set it equal to those non-adjacent and inside angles. So that's going to be 27 plus x. We got to get x by itself. Subtract 27, and what do you get? What, can you say it one more time? 116 equals x. 116 degrees. And then last but not least, here we have our angle of 5x minus 10. And we know it's going to be the two non-adjacent other angles inside the triangle. So it's going to be 60 plus 60. What is 60 plus 60? 120. So we have 5x minus 10 equals 120. Combine my like terms. Add 10. So we have 5x equals 130. And x equals 26. So x equals 26. Our lesson today is 4.3 properties of isosceles and equilateral triangles. And our objective is to use properties of isosceles and equilateral triangles. So I'm going to give you a second to write it. I'll leave the video recording. Okay, I still see a couple people writing. I'll give you a second. Okay, so our first part here is we have some key terms. The first one is legs. The congruent sides of an isosceles triangle are legs. How many sides are congruent in an isosceles triangle? 2. So the 2 that are congruent are the legs, and the one that is not congruent is the base. I'm going to draw a picture. If I was you, I'd put this on my page. I put it on mine. You should put it on yours. So you see that you have 2 congruent sides here, and I'll fill that out. So these are going to be my legs. We also have our base. And then these angles that are at the bottom of your legs connecting to the base are the base angles. Okay, and I'll give you some time again. Okay, still see a couple people writing, so I'll give you guys some more seconds. Does anybody need more time? Okay, I just see 1 or 2 more people, so I'll just give you. Okay. Okay, then we have our first theorem, the base angles theorem. So this says if 2 sides of a triangle are congruent, then the angles opposite of them are congruent. So you know if we have 2 angles that are congruent, I'm going to call those this angle here and this angle here, then you know the sides opposite of them have to be congruent. So same measure. Okay. Then we're going to solve these examples.
Dang, I don't want to finish.
Okay, so after that, now let's go here. You see you have 2 congruent sides, and based on that theorem, we know the sides opposite, or the angles opposite of those sides are going to be congruent. So the measure of angle A is how much? I hear you saying it? 82. Yep, the measure of angle A is 82 degrees. Because we know angles opposite of congruent sides are congruent. So here we're looking for angle A, but that's not the angle we have information for, right? So we know that the angles opposite of congruent sides are congruent, so which angle would that be?
B.
So we know B. And so that side is congruent, or the angle opposite of that is AC, that's the side. What, the side that's opposite of that one? Let me try that again. So if you know 67's here, right? That's the angle we have. We need the side and the angle across from it that's going to be congruent to this. Which one would that be?
C.
It's going to be angle C. So we know angle C here is 67 degrees. But that's not the angle we're looking for. We're looking for the measure of angle A. So what is the sum of the interior of a triangle? 180. So you take 180 and you're going to subtract the two angles we have. Minus 67, minus 67. Can somebody tell me what that value is? 46? So measure of angle A is 46 degrees. Okay, over here we see we have two congruent sides. The angles opposite of the congruent sides are congruent, which means the measure of angle A is how much? Okay, would you like a second to draw these guys? Okay, I'll give you a second to draw. Leaving the recording on so the people in 6 hour have time to draw as well.
I didn't even see it. I don't like it. It's messing with my eyes.
Mm-hmm.
That's what it is.
Okay, so we have the measure of angle A, and we want to find that. So we know that we have opposite sides that are congruent. So the angles opposite of them are congruent. So if we know that C is 45 degrees, what's the measure of angle A? It has to be 45 degrees. That's right.
Yeah.
Because we have congruent sides, and the angles opposite of them are congruent. Okay, here you see again you have two congruent sides, which means the angles opposite of them are congruent. So that would be angle B and angle C, or angle A. So what's the measure of angle A? 57 degrees. Nice job. Okay, and then we have this one over here. We have two congruent sides. That means the angles opposite of those are congruent. So now we have angle B. What's the measure of angle B? 79. But we want to find the measure of angle A. So we have to use that 180. And we're going to subtract the two angles we have. 79 minus 79. And that gives me what? 22. So our theorem here is the converse of the base angle theorem. So remember, the converse is where we switch the if and the then. So if two angles of a triangle are congruent, then the sides opposite of them are congruent. So the last one said if we had two congruent sides, then the angles had to be congruent. This one says if the angles are congruent, then the sides have to be congruent. I'll give you a second to write it while I leave the recording on. Did you already finish? Okay, excellent. Okay, so we're going to get started here. So now you see if you have two congruent angles, that means the sides have to be congruent. I'm going to let the video run while you guys draw your triangles for all four of them. Okay, so I'm going to let the video run while you draw all four triangles. Not. Okay, now hopefully you guys have had enough time to draw these. We are going to now start solving. So our last theorem told us if you had two congruent angles, then the sides opposite of them had to be congruent. So the side opposite of angle B is 18. The side opposite of angle C has a measure of 3x. And now we want to find the value of x. How do I get x by itself? We're going to divide by 3. So we have 18 divided by 3, which is?
6.
So x equals 6. Okay, on our next one here, we see we have two congruent angles. It's shown by the congruent angle marks. So you see those little arcs? That means the sides opposite of them have to be congruent. So we have 2x equals 15. We need to solve for x. Divide by 2. X equals? I'm okay if you write 7.5. Or you can leave it as the improper fraction of 15 over 2. Because that cannot be reduced. Either of those are fine. And then we have this one here. Again, you see you have those congruent angle marks, which means the sides opposite of them are congruent. So that means you have x minus 7 equals, side opposite of this angle is 38. How do I get x by itself?
Add 7 to both sides.
Add 7. When you add 7, x equals 45. And last but not least on this page, You have two congruent angles. The sides opposite of them have to be congruent. So that means you have 27 equals 5x plus 7. What's my first step? Yeah, you had it. Yep, subtract 7. So you end up with 20 equals 5x. We got to get x by itself. Divide by 5. X equals... I'm going to write it down here because I ran out of space. So x equals 4. Okay. So here we have the equilateral theorem. If a triangle is equilateral, then it's equiangular. So if it has congruent sides where all of them are congruent, that means all of the angles are congruent. I'm going to take a second and we're going to see what that would actually mean. If you know you have a triangle that is equilateral, you know that you have 3 congruent sides. This is telling you that means you have 3 congruent angles. But we don't know how much that angle measure is yet. So if we were going to try to figure that out and we don't know the measure, what do we represent it with? With an x, yeah. So we can put x here. We have 3 angle measures that are the same size. So you have x plus x plus x is going to be 3x. What's the sum of the interior of a triangle? 180. We want to get x by itself. Divided by 3. X equals 60 degrees. So if you have an equiangular triangle, all angles are congruent, it's going to have to mean that each angle is 60 degrees. There's no other possibility. This is Equiangular Theorem. If a triangle is equiangular, then it's also equilateral. This is the converse of the last one. So now if you know you have congruent angles, then you know the sides have to be congruent. The last one said if you had congruent sides, then you knew the angles had to be congruent. Okay, do you need another second? Here we see we have 3 congruent angles. What do we call a triangle that has 3 congruent angles? Equiangular. I'll wait a second. Sorry I jumped into it. Let's have you guys draw your pictures. I'm going to leave the recording going so you guys have time to draw in 6th hour. Are you guys okay if we begin? Yeah. Okay. So here you guys just told me this first one is equiangular. That means it also has to be equilateral. So that means all of our sides are going to be congruent. Since they're all congruent, we know that means the same measure. So we can set up 6x and set it equal to the other one, 24. How do I get x by itself? Divide by 6. That means x equals. Nice job. Our next one up, once again, you see that you have an equiangular triangle, which means that it has to be equilateral. So we're going to set them equal to each other again. 19 equals 2x minus 1. First step, add 1. We end up with 20 equals 2x. How do we get x by itself? Divide. Exactly right. Divide by 2, x equals 10. Nice job. Next up, again, you see it. We have an equiangular, which means it's equilateral. We set them equal to each other. You have 7x plus 5 equals 26. First step, Subtract 5. Yep, 7x equals 21. Divide by 7. X equals 3. Okay, and then we are here. We have this one. And we see that we know that the angle measure is 5x. There are two ways of doing this. You can know that you have 5x for all of them since it's going to be equiangular. And you can do 15x equals 180. But we know based on what we just solved, how much is each individual measure of an equiangular triangle? It's 60. So we can take 5x and set it equal to 60, which means we just have to divide by, which gives us x equals 12. That's right.